In this session, I'm going to be going over Git Hub, providing an overview of that and how it integrates into Databricks. And some areas that I'm going to be talking about is to first provide an overview of what GitHub is, when it would be relevant to use it in your Databricks workflows, how to create a GitHub token, and finally, integrating GitHub into Databricks and leveraging all of the features in Databricks for your Git flows to create branches, pull requests, merging them, and updating them within the platform. Arif is going to be closing us out today by going over Databricks workflows to specifically describe how one would create a job, preparing the job and rerunning it, as well as going over job configurations and what monitoring would look like. So let's go to the next slide. For those of you who are not familiar, GitHub is a web-based version control and collaboration tool for developers. And the entire product is founded on the premise of Git, which is an open source code management system. So with Git, it allows you to track changes that you make to files so that you have records of all of the changes to your code and in your repo over time. And that also allows you to revert to specific versions of files should you ever need to, if there was a bug or if there were changes in direction with features and functionality. And lastly, with Git, the tool allows for collaborations to be improved because it supports multiple users contributing to a single code base and provides a process for users to review each other's code, comment on them before merging and deploying. So before moving on to GitHub concepts, I want to touch on what scenarios and when you would want to use Git in Databricks. This is important because within Databricks, there's already native functionality that supports version controlling all of your notebooks. And to describe a little bit more about that architecture and infrastructure, all of your notebook codes today are backed by S3 buckets to prevent data loss. And Databricks also provides the capability to restore notebooks if you inadvertently delete them. So being able to restore them from your trash is also possible. Similar to a Google Doc experience, as you are doing development in your notebooks, it will also autosave and does similarly support reverting back to previous versions as well. And through your notebooks, you have the capability to share them with other members on your team. And if you have the ability to do so and are given privileges to do so, you can comment directly in those individual cells to provide your feedback. So with all that in mind, in what scenario would you use repositories in Databricks? So a couple of instances come to mind. The first and the primary instance would be if you were setting up advanced Git automation using CI/CD workflows such as GitHub Actions to be able to control deploying your code on a merge event. So in that particular case, if you are operating within GitHub, doing pull requests and merging, you can configure a GitHub action to essentially deploy it to a specific account to actually run in production. And that will give you the ability to schedule jobs that reference those particular notebooks in your Databricks repo rather than in your account. And so for the remainder of the demo, I'm going to be going over how to generate the token, how to integrate it within Databricks. This will apply if you already have existing access to GitHub. So on the next slide, before I go through the typical GitHub workflow, I want to highlight and touch on some concepts that are going to be important for you to be aware of. The first is when it comes to your code base, your code is going to be stored within a GitHub repository, and it's going to contain all of your project files, all of your notebooks and SQL code, and also contain the entire revision history. The repositories can have multiple versions in the form of branches for users to be able to do your development. And typically the stable production version of a repository is always going to be the main or the master branch. For every single change that you make to your branch, those are going to be updated in your branch as commits. And a commit is essentially going to be a snapshot of the project with those newly specific, the newly added changes. And the best practice here is that when you are committing a set of changes, always include a descriptive commit messages so that it can be referenced later. And then finally, with the branches that you are creating, leveraging a pull or merge request and adding reviewers from your team will allow for others within your team to provide feedback on that particular branch and give you an opportunity to incorporate those changes. So on the next slide, the picture illustrates a typical workflow where the production main branch, as you can see, is going to be in that middle master branch. And from that particular master branch, you can create your own branch where you do your work towards the top, but someone else on your team can create their own branch as well on the bottom. And with this specific flow, multiple users on your team can contribute to a single code base by putting up pull requests, reviewing them, and then merging them at different times, as you can see as they merge back into the master branch. Okay. With that, on the next slide, let's go ahead and move on to our demo. So I'm going to share my screen. Okay. Are you able to see my screen from here?
Yes, we can.
Excellent. So I am in the GitHub page, and the very first thing that we're going to have to do in order to set up the Databricks integration is to generate a GitHub token so that Databricks can reach out to GitHub under your user to be able to clone and make changes to your repository. So to be able to do that, you'll want to go to your settings. And then towards the bottom, you'll go to developer settings. And then here, you'll want to go to the personal access token menu. So specifically for Databricks, you will want to generate the classic token. And then here, when you generate that specific token, you'll use the classic for general use. You'll give that token a name. So let's call this Databricks demo token. It will default to 30 days. And at minimum, this token will need access to repo. To your repo. So you'll need to ensure that you select that as a scope. And depending on how advanced your workflows are, if you are contributing to GitHub Action workflows, you may also need to select giving access to the workflows as well. But for this particular case, I'm just going to set it for repo. So towards the bottom, we'll generate the token, and then the token will appear. So I'm just going to save this over here, just temporarily. Let's just put it temporarily in a notebook, just putting it right there. And then once you get back to the GitHub page, what you'll need is to configure single sign-on. And so with this particular token, you'll need to allow it to authorize to the group that you are associated with within CMS. So for me, that's just the CCSQ key-DAS page. And this can require me to log in again. So I'm going to enter in my MFA. And here, now the credential is authorized to access that particular group and all the repositories associated with that group. So moving over to the Databricks side is where you'll need to configure that token that was saved earlier. And so I'm going to open up, I think I still have it copied, I do. So you'll want to go to the Git integration page here. You'll want to put in your Git provider username or email. So in this particular case, I'm going to just put my email. And then here is where you're going to be pasting that specific GitHub personal access token that you generated earlier. Okay. So now that you have configured your tokens, you can move on to cloning and adding a repository. So here at this point, I'm going to go back to my profile and pull up a sample repository that I created. I know it's private, called my repo. And within GitHub, I'm going to copy the HTTPS address for that repository. And then jumping back to Databricks is where I'm going to paste it. And then it's going to default to the repository name, my-repo. And then if you have multiple tokens that are generated, you can also specify the Git credential that you want to use there. So at this point, I'm going to go ahead and create that repo. And then if I go to this repo, you can see here that the only thing that's available now is the README, right? So you can also see that when you jump to that specific repository, that's the only file that's there. So now let's go ahead and walk through what the GitHub with the Git workflow will look like directly in Databricks. So what I'm going to do is jump back to the notebook that I had earlier when I was going through the exploratory data analysis. And here, I'm going to clone this, basically make a copy of this notebook into my repository. And this is just for the sake of the demo. Of course, once you have cloned a repository, you can create notebooks directly from that menu as well. So I'm just going to go ahead and clone it here. All right. So next, I'm going to create a branch, right? Because right now I'm on my main branch. I want to make sure that I create like my test branch. I'll go ahead and create that. You can do that directly in Databricks. And you'll notice that you are now in that test branch that was just created. So here in this menu is where you can select the specific files that were either added, changed, or removed. And so in this particular case, since I had cloned that previous notebook that was created in Databricks into my repository, it's going to show up that this is a brand new file in this repo. So here, I'm going to say committing my first file, and in the description, I'm going to add omitting the exploratory data analysis demo into my test repository, my test repo. So here, I'm going to go ahead and commit that to the branch. And you'll get the success notification that it was committed properly. So this is also a neat functionality, but directly in Databricks, you can create a pull request from here without having to set it up in GitHub directly. So Databricks provides this quick link to create that pull request, and it's going to jump directly to an open pull request where it's going to pull in the last commit message you had, where it's pre-populating the pull request title to be committing my first file, where the description was what I had entered earlier, committing the exploratory data analysis demo into the test repo. So here is where you can start to select other users within their team to be added as reviewers. And then finally, you can create the pull request. At this time, the pull request review process would be underway where the reviewers that you've assigned to your pull request would start to go in, review the changes that you made, add comments directly to this pull request, or simply just approve it with a message. And so since I don't have a reviewer, and this is my private repo where I don't have rules set to prevent me from merging, I have the ability in here to just merge that pull request, which I'm going to go ahead and do now. So I'm going to confirm this merge. And then now my test branch changes have been merged into the main branch. And just as best practice, it's always good to delete your branch so you don't leave any phantom branches hanging. So at this point, you can go back into Databricks and update the repository to go back to the main branch. And when you do, you'll notice that specifically in this particular branch, that you've already pulled down the changes that have come from the previous branch that I had merged. So the exploratory data analysis demo notebook is now committed, and you are back in your main branch. And this would be the process to which you would integrate GitHub, what you would follow Git workflows to create branches, generate pull requests, and to ensure that the repositories in your account are updated with latest changes from all of the other users within the team. Okay. And with that, that concludes the demo of GitHub, and I am going to turn it over to Arif.
Thanks, Philip. Let me go ahead and take over the screen. Okay. All right, so let's quickly kind of give an introduction to workflows. So let me just make my screen a little bit bigger for you. There we go. Okay, so first I want to show how you're going to navigate to workflows within Databricks, and then I'll just give you a quick description of what workflows is. So if I'm starting from the home screen inside of Databricks, I'll see kind of my main selection menu, which shows me the workspace, the repos, which Philip was just demoing, kind of shows me my recent files. And then finally, I can jump into my data or workflows. So I'm going to go into workflows. Workflows is really a combination of two components. The first is jobs, which is what we're going to focus on today. And then the second is Delta Live tables. So I don't plan to focus on Delta Live tables today, but just to distinguish between the two, I'll mention that Delta Live tables is kind of purpose-built for ETL. So it has, really, kind of purpose-built syntax to make it really easy to build out ETL pipelines, does a lot of the dependency management, does a lot of the monitoring outside of the box, and also has an optimized engine for ETL. But what we're going to talk about today is the jobs component, which is a little bit more of an all-purpose orchestration tool. So this isn't just for ETL. This isn't just for Spark. It's not just for Databricks, as you'll see in just a second. This is more so an all-purpose orchestration tool, similar to, if some of you are familiar with Airflow. The same way that you would use Airflow is the way that you would use workflows or the jobs component of workflows. So just to quickly jump in, I'll create a job. And I'm going to talk through some of the settings that you see when you first go to create a job. So the first thing that we're going to be prompted to do is just define a task. And we can have different types of tasks. So I'll just call this task 1, just as a quick example. And we can have different types. So commonly we'll see notebooks, but we can also run Python scripts, Python wheels. We can point to a SQL file. I'm going to highlight a couple of others that may be relevant either now or in the future. So I mentioned Delta Live tables. Delta Live tables can actually be embedded within a workflow. The same thing is true for DBT, for jar files. Spark Submit, some of you may be familiar with Spark Submit jobs that can also be run as part of a workflow. One thing I'll highlight is that when you're using Spark Submit jobs, the compute cluster has to be a jobs cluster. And you'll see in a second that that's not always the case. Other thing I'll note that will show slightly, a different variation of compute cluster is the SQL files. So in this case, you're going to see that the compute for a SQL file is a warehouse. So again, when I go into the notebooks, you'll see that there's a little bit more optionality. Whereas when we're running SQL, it would make sense that we're going to run that specifically on a SQL warehouse. Okay, so now let's just go back to a notebook and let's talk through some of the options. So the first thing that I would do is just point to the notebook. So I'm going to just browse through my workspace. I could either choose the workspace itself, which is where I would have my user folder, or the repos. So if you're using repos, as Philip just demoed, you could also select the repo that you want to pull from. So I'm going to go to the workspace. I'm going to go to my user folder. I'm going to go to a folder that I have here with some tasks defined. So I'm going to go ahead and select the Create Tables task. And then the next step, once I define the path of my notebook or my Python file or whatever it is that I'm orchestrating, in this example, a notebook, I'm going to then select the compute. So one thing I want to highlight, today you won't see serverless compute. I'm using that while I'm demoing because it's just a little bit quicker. So that will definitely be an option or maybe an option for you in the future. But what I want to highlight is kind of the way that you all would see the compute, which is the classic jobs compute. So you have a couple of options when you create a workflow. Let me just go back one level. We could either go ahead and just add back to the classic jobs compute. So we could either just have a compute a jobs cluster created for us by default, or we can go into this UI that you just saw when we can specify the specific parameters around the compute cluster that we want to create. One of the things that I'll highlight is this policy. So you can see that I'm an admin in this account, so my policy is unrestricted. You'll likely have a policy that kind of restricts some of these different knobs that you see that I'm able to set. So you'll be a little bit more limited in terms of the different parameters that you'll set. Another thing that I want to highlight that I think always kind of confuses people when they first start working with jobs clusters, especially if you're familiar with Spark clusters in general, is that it only has one parameter for workers. So if you've ever worked with a Spark cluster before, even taken a look at the Spark cluster config, you're used to seeing a min and max value. In the case of jobs clusters, it's expected that you're going to size them to the workload. So it just specifies the number of workers, and that number of workers is fixed. You can specify the worker type, the driver type. Again, you'll see that some of these will be pre-filled or some of these will be limited based off of the way that your cluster policy is set up. Okay, so I'm going to go ahead and cancel out of there and highlight a couple of other things. I could also specify dependent libraries. So if I'm using a library that if I was working in a notebook on an interactive cluster, I would have to pip install or install by any other method, then I can actually specify that as a library dependency. And when I run my job, Workflows is going to go out and it's going to install those libraries on the cluster so that you have them available. So if you're using any sort of import that is referencing a library that's not available by default on the Databricks clusters, then you'll go ahead and specify the dependent libraries when you define your job. Another thing that you can do is specify parameters. So you have different types of parameters. You have parameters that you can set and you can kind of manually configure for a specific task. You also have parameters that you can set, as I'll show in a second, at the entire jobs level, which will be shared between tasks. So you can pass those parameters back and forth. So you can think about an example, for instance, if you wanted to have the output of one job feed into the input for another job, you're able to do so. Or even if you were running multiple models and you wanted to have a job that then compares some of the performance metrics for all of those models, you could pass in those performance metrics to that last job. Emails. So this is notification that I can set on when my job starts, if it's successful, and upon failure. There's other notification methods that would need to be configured if you have those available. So for instance, Slack is another option as well. Okay, and then I can set my timeout and I can set the number of retries that I want for this workflow to attempt to try to retry if it fails on the first attempt. So what I'm going to do now is actually jump into a pre-built example. So I'm going to go back one level and I'm going to go ahead and jump into this demo job. And I'm going to take a look at my task, and then we can kind of just talk through each of these tasks and the configuration that we see here. So a lot of this is what I've already explained, the ability to specify the task type, the source. I'm going to specify the path, the compute type. In this case, I don't have any dependencies. So I don't have any dependent libraries. I don't have any parameter set. And this doesn't depend on any other task. Whereas if we look at task 2, it actually depends on task 1, right? So we can see that in our DAG visually, but this is how we would specify it inside of our definition or our configuration for the job. So I could also say that it depends on multiple tasks to complete. So depending on the flow of your overall job, you're going to want to set the dependencies for each of your tasks. So I'm just going to get rid of that. Other thing that I can show here is an example of a parameter. So here I was just showing, a very trivial example of a parameter that I can set to whether or not I want to run that task. So I could set this to yes or no. If it's yes, then I'm going to run that task. If not, then I'm going to skip that task. you can imagine this would be an example, maybe if you're going to run the same exact job config in multiple environments, but maybe there's a step that you only run in dev, and there's a different step that you only run inside of prod. Also, what I'll highlight on the parameters, if I was going to define a new one, is the ability to browse some of these dynamic values. So you could reference the job ID, the job name. I gave the example of only wanting to run in specific environments. So here you can actually specify the environment ID or the environment URL. So that would be an example where maybe you could implement something like that. And then here I can also specify if I want to run, if all of the dependent tasks are completed successfully, if at least one of them are completed successfully, or if at least one failed, right? So I can specify under what conditions I want to run the specific task that I'm working with. Okay, let me go ahead and cancel out that. And I'm going to actually go into one other example. So I'm going to clone this. And when I clone this, I'm going to start to mess around with it a little bit. I'm going to show you one of the examples that I think is going to be extremely useful, especially if you're running long-running jobs. So I'm going to show you how you would monitor these workflows and then how you would potentially repair and troubleshoot if you have any issues. So let me go ahead and kick this off as I'm talking through it. This is probably going to take about a minute for us to start to see the first job actually start to execute. And if I want to monitor that, I can actually switch from this task tab to my runs tab. So my runs tab is going to actually show me in real time each of my tasks running. So here I can see that none of the tasks have started up yet. I'm just now starting to start the cluster. Once that cluster starts running, I'll start to see my first task, task one, start to run. While we're waiting for that to run, let me talk a little bit about some of the details that we have over here. So I just manually ran this entire job, but we can also add triggers. So for instance, I can say that I want to run this on a specific schedule, and I can specify when this should be run, or I can also just specify that this should be run continuously. The schedule is probably most common. I imagine that's what most of you will be doing, where you can specify cron syntax and you can say, okay, I want to run this, every day at a specific time. Okay, now we can start to look at some of the tasks that are being executed. So I'm actually going to click on it, and I can see in real time the notebook that is associated with that task, which is a really nice feature. And I can start to see that the jobs is kind of stepping through this notebook. So I can see the output similar to the way that I would be able to see it if I was working from an interactive cluster. So if anything fails, I can start to see that fail in real time. And as that one is running, I'm actually going to go ahead and jump into one of these notebooks. So let me go to task 2, and I'm going to show you how you can jump into the notebook and start to edit it. So I'm just going to go ahead and click open the notebook that is associated with that task, and I'm going to mess something up. So I'm just going to put error, which isn't a variable, so it's not defined. It should cause this to break. And I'm going to kick off another job run so that we can see what happens when this breaks. So if I go back here, I'm going to go ahead and kick off another manual job run, and we're going to expect that one is going to break. In the meantime, we can jump back to the run that is currently executing, and we can see that it's stepping through each of these tasks. We can take a look at the duration, the start time, the end time. Here's another place where it's going to show me the details around the notebook, the status, etc. And then we're going to wait for this second one to start back up. Oh, let's make sure that one actually is. So this one actually failed, right? So what we're going to want to do is, if we have a task like this that fails, and let me see one thing. This one was skipped. So I'm going to start it again because I don't want it to skip. I want it to fail on that specific session. So this is just going to rerun everything, and hopefully we can get it to run. And then I want it to fail on a specific step so that we can show how we can start from a specific step and then start to repair any issues that we have with our job at a specific step and go from there. So let's go back to our runs. Oh, so that's a good example where I set the max concurrent runs to 1. So this is why this originally was skipped, because my max concurrent runs was set to 1 and my first run was still running, it automatically skipped this one. So if I go back, I can now kick off a second run because that one is completed. So now I can view that run, and this is the one that we want to go ahead and fill so that we can see how we can start to step through. And again, this one is going to go ahead and bring up the compute. Takes about a minute to bring up the compute. Once it brings up the compute, we can start to see that it's going to step through the task. And what we expect is, I believe it's task 3, where we modify the notebook. So we're going to expect that it's going to fill on that task. And this is a use case where, again, let's say each of the tasks, each of these notebooks is running for hours or multiple hours, and one fails, right? What you used to have to do is you had to go back, you have to troubleshoot what caused the error, you have to fix it, and then you have to start all the way from the beginning and run everything again. So you now have this really, really cool feature where you can go ahead and say, okay, if task 3 is the one that failed, I'm going to go to task 3 specifically. I'm going to see what my error was. I'm going to try to fix that error in task 3. And then once I fix the error in task 3, I'm going to rerun this, and I'm going to kind of pick up where I left off. So here we can see us stepping through. We're running through task 1. Then we should move on to task 2. And then we want to take a look at task 3 and see if it fails again. As we're doing that, let me just bring up one other screen and kind of show this main UI when we first enter into this. I kind of glossed over this when we first jumped in. There's a couple of things that you'll kind of just want to take note of here. One is the ability to switch views. So if you ever jump in here and you have a job that's been shared with you and you don't see it, you want to make sure that you're actually looking at all of the jobs that are accessible to you and not just the ones that are owned by you. So you can kind of quickly filter through those. You can also search through jobs. So, if I wanted to search through, any job that has demo, I can see the different jobs that have the word demo in it. I can see that across the jobs that are owned by me, as well as the jobs that are accessible by me. I can also specify the columns that I want to see here as well. So let's say I was looking for a specific job by ID. I could specify those columns. I could specify tasks, or even if I was looking for a job by cluster. Let's jump back and see if our last run failed. It did. So we're going to take a look at it. We're going to say, okay, this run failed. We need to try to fix it. I can see that it actually failed on task 2. And then all of the dependencies for task 2, all of the downstream dependencies are also failing. So if I go to task 2, I can bring open that notebook again. We can see the error that I added. So I'm going to get rid of that. I'm going to go back. And I'm going to say, let me go ahead and repair the run. So now what we want to happen is that it's not starting from task 1. Task 1 already succeeded. Task 4 already succeeded. Task 3 is starting directly from task 2. So it's going to try to rerun task 2, and then it's going to try to rerun all of the downstream dependencies. So again, very efficient way to kind of be able to troubleshoot without wasting a ton of compute on a job that started and failed after an hour or 2 hours or so. Okay, as that's running, we're going to jump back and forth to make sure we're kind of making the most use of time. So I'm going to jump back into the UI. So let me go back to workflows here. And I'm going to bring up the ones that are owned by me. I'm going to bring back up my clean example. I'm going to take a look at my task. And I'm going to just highlight a couple other things inside of the UI that we haven't showed. In fact, one thing that I probably should highlight, especially because we're kind of coming on the wheel of the Git session, is the ability to actually be able to point to a Git repository. So here I'm pointing to a notebook. That could either be in the workspace or it could be inside of my Git provider. So I could just point to a Git repository, assuming that I have my credentials configured. I could do the same thing for really anything that's supported in Git. So I could do the same thing for a Python script as well. Let's go back and see if our run is now succeeding. So we can see task 2 is running. We can see that it's starting to step through. we're running the first command. So if we get through that first command, we would expect that everything else is going to run successfully. And then all of the downstream jobs should run successfully as well. Notice that this is the same kind of monitoring row. So it doesn't actually start a new job. This is the same job. So it's going to go from the failure that we saw previously, and it's just going to update the status. So previously task 2 failed, but now it's just showing that task 2 succeeded, and it's showing me all of the downstream tasks. Okay, so with that, I think we can wrap up. And obviously, a really important feature, workflows, is kind of how you start to, put some of the work that you're going to want to put into production. So once you do some of your, ad hoc development inside of an interactive notebook, and you say, I now want to, go ahead and schedule that notebook as a job, so that I can run it on some, specified schedule. So this is definitely going to be an important feature that I'm sure you're all going to leverage. Last thing that I'll highlight about workflows is you want to take advantage of jobs compute when you can. So sometimes what we see is the tendency to actually go ahead and run a notebook manually every day. So you're treating it as a job, but you're running it manually every day, or you're running it from an interactive cluster. And that tends to be a very inefficient way to use Databricks, because you actually are charged less for running as a job. So whenever you can, if you have something that is repeatable and you have something that you want to use over and over again and you want to run on a schedule, you're going to want to make sure that you're leveraging jobs to do so in jobs clusters.